For a century, one theory about Stonehenge's stones was treated as settled. In 2026, a computer model ran the numbers. The theory did not survive. Part 1. The stone that shouldn't be there. Stonehenge sits on Salisbury Plain in southern England. Everyone who visits it is looking at the wrong mystery. The real question isn't the ring everyone photographs. It's one stone lying almost flat at the center, half buried under two collapsed Sarsens, the altar stone. For 100 years, geologists assumed it came from Wales, like the smaller bluestones around it. Same region, same story, case closed. In 2024, a geology PhD student named Anthony Clark, working out of Curtin University in Australia, tested that assumption almost by accident. He analyzed the age and chemistry of microscopic mineral grains, zircon, apatite, rutile, locked inside fragments of the altar stone. Each mineral grain carries a kind of fingerprint. The exact age it formed tells you which region of the Earth's crust it came from. The fingerprint did not match Wales. It matched a region 750 kilometers away, and once that number was confirmed, it created a problem nobody in archaeology wanted to touch. Part 2. 700 kilometers. The altar stone's mineral signature traced back to the Orcadian Basin in the far northeast of Scotland, practically the opposite end of the British mainland from Salisbury Plain. Clark published the finding in Nature in August 2024, alongside co-authors Nick Pierce, Richard Bevins, and Rob Ixer, geologists who had spent almost 2 decades trying to pin down where this specific stone belonged. Every other megalith at Stonehenge has a known, comparatively local source. The Sarsens, the towering outer stones, each over 20 feet tall and around 25 tons, were matched in 2020 to Westwoods, roughly 15 miles north. The bluestones came from the Preseli Hills in Wales, about 140 miles away. Hard journeys, but explainable ones. The altar stone broke the pattern entirely. 750 kilometers is not a difficult haul. It's a distance that, for Neolithic Britain around 2600 BCE, raises a question nobody had a ready answer for. How does a 6-ton block of rock travel the length of the country with no wheels, no draft animals suited to the job, and, if it went by land, mountain ranges and river systems in the way? Co-author Nick Pierce noted that no other stone used in any monument from that era is known to have traveled this far. Rob Ixer, another of the co-authors, called the result genuinely shocking, not because the mineral science was in doubt, but because of what it implied about the people who moved it. For a while, one explanation offered an escape hatch: glaciers. If ice sheets from the last ice age had dragged the stone partway across Britain before retreating, the human effort required would shrink dramatically. Nature does the hauling, people just finish the job locally. That escape hatch is what the 2026 analysis was built to test. Part 3. What the model ruled out. Early in 2026, Clark and fellow Curtin geologist Christopher Kirkland ran a new study, this time not on the stone itself, but on the ground around it. Their method? Search the river sediment near Salisbury Plain for the specific mineral traces glaciers leave behind. When ice sheets grind across a landscape, they don't just carry rock, they shed it, gradually, into the rivers and sediment downstream. If a glacier had ever carried Scottish rock anywhere near Stonehenge, the signature should still be sitting in those riverbeds today, preserved for thousands of years. The team modeled the last ice age's glacial reach across Britain and searched for that signature directly. They examined over 500 zircon crystals from sediment near the monument. They found nothing, no glacial signature, no trace of ice-transported rock from the north anywhere near Salisbury Plain. The model showed glaciers plausibly reaching as far south as Dogger Bank in the North Sea, but not further, and nowhere near southern England. Clark's own conclusion: this wasn't ice doing the work, it was people, moving the stone deliberately, across difficult ground on purpose. The escape hatch closed. Every kilometer of that journey was down to people. Part 4. The question the model couldn't answer. Here is what should unsettle you more than the distance. Ruling out glaciers didn't solve the mystery. It just stripped away the only explanation that didn't require serious human intention. What's left is harder to explain, not easier. A 6-ton stone, moved roughly 700 kilometers by a culture with no wheeled transport suited to the terrain, no draft animals bred for hauling loads that size, and no ships built for known Neolithic sea crossings of that scale. Because if it went by land, it crosses mountains and major rivers, and if it went by sea, it's one of the earliest large-scale maritime transport efforts ever proposed for prehistoric Britain. Nick Pierce didn't pretend the new study solved that part. Their own research team said outright that answering how it got there wasn't even the goal of the analysis, only where it came from. The transport method remains, in their own words, unresolved. And the altar stone isn't an isolated oddity. It sits inside a monument where every other major stone type tells the same underlying story at a smaller scale. Sarsens hauled from 15 miles out, bluestones from 140 miles across the Bristol Channel. Whoever organized this treated distance as a solvable logistics problem over and over, escalating each time, culminating in one stone dragged the length of the country. Part 5. The quarry that proved it wasn't ice. Long before any zircon crystal was tested, one team had already gone looking for proof the bluestones were quarried, not scavenged from loose, ice-dropped boulders, and they found it in the ground itself. In 2011, geologists Richard Bevins and Rob Ixer traced one of the bluestone rock types, a foliated rhyolite, to a specific rock outcrop in Wales called Craig Rossi-Felin in the Preseli Hills. A separate outcrop nearby, Carn Goedog, matched the source of the spotted dolerite bluestones, the ones with the distinctive white flecks running through blue-gray rock. That gave archaeologist Mike Parker Pearson of UCL and his team something no glacial theory could explain away: an exact quarry, not just a region. They excavated both sites. What they found were quarrying scars in the rock face matching the shape of the missing bluestone pillars, stone and wooden wedges still lodged in extraction cracks, and, at Craig Rossi-Felin, a man-made platform archaeologist Colin Richards identified as a loading bay, built to lower cut stone pillars onto wooden sledges for the journey out. Charcoal recovered from that loading bay dated the quarrying to around 3000 BC at Craig Rossi-Felin, and slightly earlier, closer to 3400 BC, at Carn Goedog. That result did two things at once. It gave archaeology its clearest proof yet that people, not retreating ice sheets, physically extracted these stones by hand. And it opened a stranger problem underneath the one everyone thought they were solving. The bluestones weren't erected at Stonehenge until around 2900 BC, which means the gap between quarrying and arrival isn't years, it's centuries. Part 6. The 500-year gap. Parker Pearson did the math himself, and even he didn't like the shape of the answer. 300 to 500 years sit between the day those stones were cut out of the Preseli hillside and the day they were finally raised on Salisbury Plain, 140 miles away. His own read on it: dragging a stone for 5 centuries is not a realistic scenario for any culture, however patient. Something else has to explain the gap. The leading theory his team has proposed is stranger than a slow journey. The bluestones, they argue, were likely erected first in a monument close to the Welsh quarries, a complete stone circle, built and used for generations in Wales, before being deliberately dismantled, hauled across the country, and re-erected at Stonehenge. Not one long haul, 2 acts of construction, separated by centuries, using the same stones. Nobody has found that first Welsh monument intact. Geophysical surveys around the quarries have flagged promising sites, but as of the most recent published work, the case remains circumstantial. Real enough to take seriously, not yet proven enough to call it settled. Sit with what that theory implies if it's right. A community didn't just move heavy rock once, they built with it, lived alongside it, and then took it apart on purpose to build something bigger somewhere else, carrying not just stone, but a monument's entire history across a country with no maps, no wheels suited to the terrain, and, as far as anyone has found, no draft animals bred for the job. Part 7. The other match. The Sarsens, the giant outer ring everyone pictures when they hear the word Stonehenge, went through their own version of this detective work. For decades, their exact origin inside the broader Sarsen stone region of southern England was unconfirmed. Then, in 2020, a research team led by geomorphologist David Nash at the University of Brighton ran a portable X-ray fluorescence scanner across 52 of the standing Sarsens, building a chemical signature for each one, comparing trace elements that vary slightly from outcrop to outcrop, the way a fingerprint varies from finger to finger. Nash then took a core sample, drilled from one Sarsen decades earlier and stored ever since, and matched its chemistry against Sarsen fields across southern England. 50 of the 52 stones matched a single source, West Woods in Wiltshire, about 15 miles from Stonehenge. Only 2 stones, including one of the most studied stones on the entire site, came from somewhere else, a source that to this day has never been identified. 15 miles sounds almost mundane next to a 700-kilometer Scottish journey. It isn't. These are stones weighing around 25 tons each, and the team behind them still had to shape, transport, and raise 50 nearly identical blocks from one location, while somehow also incorporating 2 outliers from an origin nobody has traced. Even the easy stones in this monument carry an unanswered question. Part 8, the stones that ring. Now for the strangest verified fact in this entire story. Some of the bluestones sing. Starting in 2007, a research project run under the Royal College of Art in London called Landscape and Perception, led by Paul Devereux and John Wozencroft, went into the Preseli Hills to map what the landscape around the bluestone sources actually sounds like. They walked the outcrops with small hammerstones, striking rock after rock, recording the results. What they documented and published in the journal Time and Mind is that a significant proportion of the rocks along the Carn Menin Ridge, the heart of the bluestone source region, are what geologists call lithophones, ringing rocks. Strike one, and instead of the dull clunk stone normally makes, it rings, a clear, metallic, bell-like tone. Different rocks ring at different pitches. Devereux put it simply in interviews at the time. There are enough different tones out there that you could play a tune. And here is the detail that connects it back to everything else in this video. Carn Godog, the outcrop that Bevans and Ixer confirmed as the main source of the spotted dolerite bluestones, the one with the excavated Neolithic quarry, is full of them. The project recorded lithophones at Carn Godog, ringing clearly enough to be heard 300 meters away across open hillside. There is even evidence at Carn Menin that some ringing rocks were deliberately struck in prehistory, percussion marks in the right places, on the right stones. So the question archaeologists have chewed on ever since, is this why these specific stones were worth hauling 140 miles when perfectly good rock sat closer to Salisbury Plain? Nobody can prove it. The sound of a stone leaves no trace in the archaeological record once it's standing silent in a field in Wiltshire. But the coincidence is uncomfortable. Of all the rock in Britain, the builders fixated on outcrops that ring like bells, outcrops that local tradition, centuries later, still treated as special. The village nearest the source hills is called Main Clochog. In Welsh, that means ringing stones. Part 9, the sound inside the circle. That question, did sound matter to the builders, didn't stay a speculation. In 2020, someone tested it. Trevor Cox is an acoustics engineer at the University of Salford, a man who spends his career modeling how concert halls and opera houses handle sound. He spent 18 months building something no one had built before, a complete 1:12 scale model of Stonehenge. Every stone, including the 157 stones the monument had around 2200 BC, more than double what survives today, 3D printed from laser scans supplied by Historic England, with the model materials treated to reflect sound the way real Sarsen does. He put the whole thing in a semi-anechoic chamber, a room engineered to kill outside reflections, surrounded it with speakers and microphones at 20 positions, and played frequency sweeps through it at 12 times normal pitch, so the shrunken sound waves would interact with the shrunken stones exactly as full-size sound interacts with the real monument. The results were published in the Journal of Archaeological Science. Inside the completed circle, sound behaved differently than anyone standing in today's ruin would guess. Reverberation lingered, around 0.6 seconds for mid-range frequencies, despite the gaps between stones. The geometry amplified the human voice by more than 4 decibels. Music, drums, horns, got a boost of roughly 10 to 20% in the inner sanctum, and the effect had a direction. The stones held sound in. Speech and music generated inside the circle stayed inside the circle, barely reaching anyone standing outside, whose view in was blocked by the same stones. Whatever happened in there, acoustically and visually, was for the people inside and no one else. Cox's team pointed out the contradictions sitting inside that result. A monument that took enormous numbers of people to build, engineered, deliberately or not, so that only a small number could ever fully witness what it was for. One honest caveat, because Cox himself makes it. His measurements suggest sound was probably not the primary reason the stones were arranged the way they were. Rearranging the bluestones changed the acoustics only subtly. The amplification is real, measured, repeatable, but it may be a consequence of the design rather than its purpose. The stones will not tell us which. Part 10. The hole the size of a city block. Zoom out from the stones themselves, and the mystery gets bigger, not smaller. 2 miles northeast of Stonehenge sits Durrington Walls, a Neolithic henge already known to be the largest of its kind in Britain, a massive circular earthwork enclosing what was likely a settlement. In 2020, a research team led by Vince Gaffney at the University of Bradford, working with the University of St. Andrews and using ground-penetrating radar and electromagnetic surveys across kilometers of open countryside, found something underneath it that nobody had mapped before. Roughly 20 enormous pits, each around 10 meters across and up to 5 meters deep, arranged in a ring more than 2 kilometers in diameter, completely encircling Durrington Walls and the neighboring timber circle known as Woodhenge. Follow-up research published through 2025 using borehole coring and sediment dating confirmed at least 16 of them form a genuine, deliberately placed circuit, not natural sinkholes, which is what some geologists assumed before anyone dug down to check. Gaffney called it, in plain terms, a structure without precedent anywhere in the UK, larger in footprint than Stonehenge's entire stone circle, dug by hand into chalk bedrock, in a ring wide enough to enclose an area of more than 3 square kilometers. Nobody has a confirmed answer for exactly why. The leading theory is that the shafts marked a sacred boundary, a line pilgrims were guided toward, or warned not to cross, around a site already understood to be a ceremonial center. But that's an interpretation, not a settled fact, and the researchers behind it say as much. What it confirms, at minimum, is that Stonehenge was never an isolated structure. It sat inside a landscape where Neolithic communities were already capable of organizing labor on a scale that dwarfs the stone circle most people come to see. And that landscape is still giving up features this large, this close to one of the most studied archaeological sites on Earth as recently as 5 years ago. Part 11. The older mystery. Nobody has retired. The altar stone isn't the only unresolved number at this site. Ringing the inner earthwork are 56 pits, spotted in the 1600s and named the Aubrey Holes after the antiquarian who first mapped them. For most of the 20th century, they were treated as an afterthought. Some held cremated remains, most sat empty, and the uneven spacing between them was written off as imprecise digging. In the 1960s, astronomer Fred Hoyle and researcher C.A. Newham independently noticed something in that spacing. 56 is almost exactly 3 times 18.6, the number of years it takes the moon's orbital nodes to complete one full cycle, a slow wobble that governs when and where eclipses can occur. Their theory? The ring wasn't random. It could function as a long-cycle lunar tracker, a way to predict eclipse seasons decades in advance, built by a culture with no written mathematics. That theory has never been proven. It's also never been retired. Archaeologists have argued over it for 60 years, and the debate is still open. Because the alternative, that Neolithic Britain was tracking an 18.6-year astronomical cycle with no writing system, is exactly the kind of claim that demands the evidence hold up perfectly before anyone accepts it. And the skeptics have real ground to stand on. Critics, including archaeoastronomer Clive Ruggles, have pointed out that with 56 holes to work with, some numerical relationship to some astronomical cycle is almost guaranteed to turn up by chance. The sky offers enough different cycles that finding one that roughly fits isn't, by itself, proof of intent. The honest answer is that nobody has settled this either way. It's a 60-year-old argument between this is deliberate and your pattern matching noise, and it has never fully resolved in either direction. Take the Aubrey Holes and the altar stone together, and a pattern starts to form that's bigger than either one alone. This wasn't a monument built by people guessing at the sky and hauling rock wherever was convenient. It was built by people solving hard problems on purpose. Geological ones, logistical ones, possibly astronomical ones, with tools that, on paper, shouldn't have been enough to do it. The zircon crystals that gave up the altar stone's origin are smaller than a grain of sand. They sat inside that stone for 5,000 years, saying nothing until the right test finally asked them the right question. Nobody has run that test on every stone at this site yet. If you want to see the things the world forgot to tell you about, subscribe. We find them every week.